For my project, I chose the material of graphene, and here's a little bit about it and its history. Graphene is a hexagonal lattice nanostructure of graphite, and it was first theorized in 1947 by Philip R. Wallace, but it was only theory up until 2004, where at the University of Manchester, two physicists were able to exfoliate a small sample from graphite using the Scotch tape method, where you place a little piece of, or you place a small amount of graphite onto tape, and when you peel it back, you get a small amount of graphite or graphene from that. And up until they were able to exfoliate samples of graphene, it was theorized to have great mechanical and electrical properties that made it a sought after material. So once they were able to start exfoliating and actually testing its properties that it was theorized to have, they found out that it had excellent mechanical strength, and it was very light and flexible, allowing it to be used in aeronautical applications and basically anything where you would want something to be flexible and light, as well as having these amazing uh, mechanical properties. It's also a very good conductor, allowing it to be used in electronics, and as well as it being a conductor, it also has resistance, so it allows it to also be applied to the use of sensors, so it can be used in sensors. So overall, the properties are it's great in many things. But the reason why graphene has these properties is because of its shape. Graphene is a two-dimensional hexagonal nanostructure. So as shown in the picture, it's in a shape of like a honeycomb, and it's a flat piece of that. And with this structure, it has more range to move electrons and have electron holes than other materials. So up until recently, methods that were available for graphene production were very expensive, time consuming, and very wasteful. And one of the pictures I have is top-down approach, and that was for a long time the main method of producing large quantities of graphene, where you put a sample of carbon in a solution, you let that sample mix fully into the solution, and then you reduce the solution, and what you're left with is graphene. With that, you have to have large amounts of solvent in solution, and then you also have to have a very pure carbon source that you're beginning with. But up until recently, in a paper published by Nature in 2019, they showed a more efficient way of producing graphene in gram quantities that and you were able to use a lot less pure carbon source, and it's called flash Joule heating, where you put the sample of carbon between two electrodes, and you put a lot of electricity through it, and then what you're left with is the sample of graphene. And compared to the top-down approach, you are able to use less pure graphite less pure carbon source, so you can use cheaper materials to produce graphene, and then you're also wasting less while producing it. You don't have to have solvents or solutions to produce it. You just have to put energy into this carbon source. Since the synthesis of graphene has been very difficult up until recently, it has not seen many uses in mass-produced products. But since since there's been more research into producing graphene, it has taken some small roles in sensors and semiconductors because of its good conductive and resistive properties. And recently, it was used in car interiors due to its favorable mechanical properties by placing a little bit into the plastic that was later formed into the interior of the car, and once they tested it, it showed to increase the strength of plastic by 20% by only adding a small amount of graphene to the plastic. The future of graphene is very promising because it's now being able to be produced at larger scales, so it will be able to cheaply be moved into products of mass production quantities. And it's only a matter of time before people start applying the amazing properties that graphene has to other industries other than just, adding some here to increase plastic strengths or, using it in sensors and stuff like that. People have already started experimenting with using graphene in biomedical devices or in energy storage, and it's just a matter of time before it starts making a headway in all of these industries. I'd like to say thank you for watching my presentation on graphene.